let's jump ahead and do a little bit of practice balancing. And let's throw a little bit of naming in there just to remind us how to do it. Okay, because that is reasonably new as well. So we're working on page 89, okay, with this set of questions. Okay, and we took a minute to write them down on a piece of paper. Okay, so first, let's name them because we should. N2 is what? We don't know. Okay, so ask your textbook. Okay, your textbook says on page 30, okay, that N is for nitrogen, right? And nitrogen comes in 2 packs, right? So it's, you just put nitrogen by itself like this, no capitals. Okay, and as we're doing this, we'll also talk about whether it's formation or decomposition reaction or the other couple kinds we haven't talked about yet. So in this reaction, we have nitrogen plus H is for happy, hydrogen. Okay, and it's gas. Gas reacts to form, not equals, and it makes ammonia. Okay, that was one of the ones that they want us to memorize. Okay, or you could call it, because it's molecular, 2 nonmetals, it would be nitrogen trihydride. Okay, if you were naming it that way. So let's put both. Nitrogen trihydride. Okay, that would be the molecular way of naming it. Okay, but that's not what we're asking. We're asking to balance the equations. What does that mean? That means to have the same amount of atoms of each element on either side of the equation. Okay, so over here we have 2 atoms of nitrogen. Here we only have 1. So we're going to need to add another one. Okay, there, done. No, just kidding. We've got to make sure that it's matching. So now we have 3 atoms of hydrogen. Okay, but 2 times 3 is 6. Okay, so I need to have 6 atoms of hydrogen on this side. Okay, so I'm going to put a 6. And then you go, whoa, whoa, whoa. That means you're going to have 12, because 6 times 2 is 12. That's way too many. We only need 6 total on that side. So let's only put 3 molecules of hydrogen. Okay, we're going to have 3 times 2 makes 6. Okay, so let's double check everything. 2 nitrogens. 2 times 1 is 2 nitrogens. Good. 3 hydrogen molecules, so we have 3 times 2 is 6. 2 times 3 is 6. Good. This one's balanced. Okay, and in terms of what type of reaction it is, let's put a different color. Okay, this one is a formation reaction because we've taken nitrogen and hydrogen as our reactants, and then ammonia was our product. Okay, so let's put that here. Let's put these are all products. Okay, all the ones on this side are reactants. Okay, and this particular equation is a formation reaction. Formation. Right? Let's take a look at 1B. Okay, let's start by naming it just because we can. CaC2. So it's got calcium, it's got carbon, okay, this one is water, okay, or dihydrogen monoxide. Okay, reacts to form calcium. And we totally recognize this. The OH is a base, right? Calcium hydroxide. Okay, and you're looking at this saying, Ms. Bohachek, you did the calcium carbon wrong. That's an ionic compound. There's a metal and a non-metal. It should say calcium carbide. You're right, it should. I was hoping you'd notice. Okay, and it didn't leave quite enough room for this poor little guy. Okay, but we'll squish it in. So C2H2, molecular, because they're both nonmetals. So we're going to go with dicarbon dihydride. Okay, I know you can totally read that. All right. So naming is fun, so let's do it even if we don't have to. Okay, now let's balance this. There are, which one do I do? I usually pick the metals first, okay, because there's usually lots of hydrogens and oxygens and they're a bit of a pain. Okay, so there ends up being more of them. Okay, let's point out a few things that are going to try to mess us up here. One is this bit in brackets. Okay, so this is showing 1 atom of calcium, but 2. This is like math, right? So whatever's in the brackets needs to be multiplied by this number. Okay, so there's actually 2 oxygens here, 2 hydrogens here, 2 hydrogens here. Okay, so let's balance it. Calcium, 1 calcium. 1 calcium, we're good. Okay, 2 carbons. 2 carbons here, 2 carbons here. We're good, hooray. Easy so far. Now let's check our hydrogens. 2 here, more than 2 here. Okay, so 2 here, 2 here. Let's add a 2. Okay, so 4 hydrogens, we're good. Okay, let's see if that lines up with the oxygen too. So now I have 2 oxygens, we're good. Oh, hooray, this is a nice easy balancing one. Okay, we didn't learn what kind of reaction this was yet though. Okay, so we're gonna wait before we name it. Let's do this one next. So you've got silicon, chlorine, water, silicon, oxygen, and this is hydrochloric acid, but let's name it as though we didn't know that. Okay, so take a minute to put the names. I'm going to hide it. Okay, and then we'll do the big reveal. Okay, no peeking. Couldn't see. Did you get it? Did you get it? Boom. Okay, so silicon, tetrachloride, because this is both nonmetals, water, silicon dioxide, both nonmetals. I think they're nonmetals. Let's check. Oh, silicon's a metalloid, so it's probably silicon dioxide. It could be silicon oxide, but I think it's silicon dioxide. Okay, and then hydrochloric acid. Let's balance. Okay, you try. You try to balance it. And then we'll do a reveal. Okay, I'm trying to be patient so you have time to do it. Hopefully that was enough time. Boom. Okay, so what did we do? We looked at silicon. Okay, we never start with hydrogens and oxygen. Okay, so I started with silicon, whatever. So one of these, one of those, we're good. Chlorine, there's 4 of these, and there was only 1. So I multiplied by 4. So now there's 4 chlorines. Okay, but now we gotta check our hydrogens because now I have too many hydrogens. So I have 4 hydrogens, and on this side I only had 2. Okay, so 2 times 2 is 4. So now the hydrogens balance. Okay, now I gotta make sure my oxygens balance too. So I have 2 oxygens on this side, and I made it 2 oxygens on this side, so we're good. We're happy. Okay, and we didn't learn that kind of reaction either, so we're not gonna label it just yet. Okay, we don't have any decomposition ones. So if we had a decomposition one, it would be like, you can't see that. Okay, it'd be like water reacts to form hydrogen and oxygen. Okay, so we would need 2 of these and 2 of those. Okay, so that would be decomposition. And if we were labeling it, we would call that water, hydrogen, oxygen, and we would put the states, liquid, gas, gas. Okay, but that's not the question we're on. We're on D. So let's see if we can remember how to name these ones with the polyatomic ions. So you've got page SR 39 that we were working with yesterday with our polyatomic ions. So have a peek at those. Okay, I'm going to do it too, and then we'll put it back so you can see. So you put the answers. I know you can't see that, so just look in your own book. Unless you can read upside down. It might be in your book. In my book, it's student reference, page 339. I will look on page 491, though. There might be on the chart on there twice. Yeah, I don't have a page 491. You know what? I wonder if they changed it because I have the draft copy of the textbooks. Thanks for letting me know, though. Okay, so hopefully you had time to name those. Okay, so hydrogen phosphate is this one. Calcium sulfate is this one. Calcium phosphate is this one. And then that's sulfuric acid. Okay, so let's balance it. Now, one of the things to be aware of is over here. I should hide the rest of this so you know what we're looking at. I'm going to find a piece of paper for you. There it is. Oh, a piece of them here. So you know we're working on this one right here. Okay, so what might be messing people up is right here. Okay, we have to know that this 2 goes inside the brackets. So there's going to be 2 phosphorus atoms, and there's going to be 8 oxygen atoms. And yeah, so the way we cut paper is right there. Okay, so there's going to be 8 molecules of oxygen here. So there's going to be lots of oxygens. This one might be a bit of a pain in the neck, but let's find out. Okay, so we don't start with hydrogen. Okay, I know we usually start with the one on the left, but we're not going to start with hydrogen. Okay, let's find a metal. Where's the metal? Calcium. Okay, there's calcium here, and there's 3 calciums on this side. So let's put 3 and see how that goes, because it's kind of a domino effect, right? What you do to one side affects what goes on the other side. Okay, so we have 3 calciums here, 3 calciums here, so those are happy. Okay, what should we check next? Sulfur? Sure, let's check sulfur next. So we have 3 sulfurs here and only 1 sulfur here, so we're going to need 3. All right, so our calciums balance, our sulfurs balance. Okay, now let's do phosphate because we don't do H and O yet. Okay, we always leave hydrogen and oxygen for last. Okay, let's do phosphorus next. So there's 2 phosphoruses on this side, and there's only 1 on this side. So let's put 2. Okay, now we're going to check our hydrogens and our oxygens to make sure those are going to work. Okay, I got to zoom out a bit so you can see the whole thing.